Hey folks, Quill18, welcome to the next part of our Unity 3D mesh creation, dynamic mesh creation tutorial. So we are going to start by creating a script at this point. And I'm going to work in C#. You can work in JavaScript if you want. There's not a tremendous degree of difference between the two. And if you don't have any programming experience whatsoever, this is not quite the right tutorial for you. What you're going to want to do is find a book or a tutorial that's really centered on learning how to program. Learn the basics. You don't need tons, but you do need the very basics of programming before you can sort of jump right into Unity here. So I'm going to call this the ground click script. So, and we're going to remember to apply it to our object, because otherwise nothing will work. So this script will simply respond to a click on the ground and create our first mesh. Our first mesh is just going to be a very basic sort of like plop it down here, and where are we going to go from there? We're gonna add more features later on. Again, I'm sort of thinking this is going to be maybe like a SimCity style road creation tool. This is sort of very rough and basic version of it, but we're gonna see where we can go from that. So we're going to open up the ground click script into MonoDevelop. We are going to tear out all this because we don't need that right now. We are going to simply make a OnMouseDown script. So when this object gets clicked, we will create something. And what are we going to create? Well, that's a good question. So there's actually a lot of different ways we can go about this. We could, if we wanted to, modify the mesh of this object itself, but I don't think that's the direction we want to go in. I think what we want to do is create a new object and populate it with mesh data, and then position it in some reasonable area. So it's very easy to do that. So what we want to do is, and what we've done in the past is we've instantiated something from a prefab, right? We might have a prefab in our assets. We've got some sort of public game object, some prefab here, right? And then we've gone and assigned that parameter here with some prefab object. And then what we've done is we've done an instantiate, right? Instantiate some prefab, and so on and so forth. And that works if the object is already defined. Again, if we're doing something like a SimCity type clone, then we might have prefabs for buildings, for example, right? And then you just instantiate the building prefab in the right position. Totally reasonable. But here we're trying to dynamically create our object from scratch. So we are actually going to simply spawn a new object. This is, we'll call it a road segment. We'll call it road. Game object road is equal to new game object, and you can give it a name in here. It is optional, but yeah, I guess we'll call it road, and we'll leave it at that for now. So now if I click, it should spawn a game object called road. It won't be very interesting, but let's take a look. So I've got maximize on play off so that we can watch everything, and it's going to be the inspector over here that's going to be not the inspector, the hierarchy view. I'm going to click. There you go. You see there's a new road added. I can keep clicking and it keeps adding these road objects. And if I can click on them, you can see they're by default they're assigned the 000 location, no scale, no rotation. But of course you can't see them. They don't have a mesh, right? They don't have anything like that. But we are indeed creating new game objects. That's great. That's step one. So I said that we need two components added to our game object. We need a mesh renderer, and we need a mesh filter. Actually, we kind of need it in the opposite direction almost. We need the mesh filter first, and then we need to be able to define how to render it. So we can feed this a series of components. And I'm betting that I'm going to get this wrong the first time I type this in, so bear with me. But I believe what we want to do is say a type of mesh filter, and then type of mesh renderer. So we're adding a series of components to this, and all we have to do is provide it with the type of component that it's supposed to create. Let's see if we've got an error. Oh, we got a warning about that, but that's fine. We click, our road indeed has a mesh filter and mesh renderer. I can't believe I got it right the first time. That's unbelievable. Yeah, I have great confidence in my abilities. Okay, so now again, we're creating the game object, we're adding stuff to it. And you can keep chaining this on. For example, if you had another type of script, if you had, some sort of road script, then you might do something like type of road script anything like that, anything that exists as a class, either one of the built-in classes or one that you've created through a script. For example, the ground click script can be tacked on like that. Presumably, it has to be derived from mono behavior, right? Because that's how the components work. But other than that, yeah, all right, good. So now we have an object with stuff. Now the hard part is just populating these sub-elements, and we can capture that. Now that we've got an object and we've assigned it to road, we can get its specific one. So mesh filter, we can call it, I'll use big long names here again. Mesh filter for the road is just road.getComponent. Mesh filter, like so. This is actually probably the biggest difference between the C# and the JavaScript implementation, because in JavaScript you would be using more the version that's like this, probably like mesh filter, like that, right? Some of the syntax is slightly different, but that's the more significant one. I really like to use the typed one, because then I don't have to do any what am I looking for? Where you convert an object from one class to another, the casting. You don't have to cast anything. All right, and we'll go ahead and grab the mesh renderer as well. We don't technically need these right now, but I'm just, just to say, okay? Get component, mesh renderer. There we go. So we've got our actual road filter and renderer in renderer. Do that all the time. And what we're really curious about right now is that the mesh filter, if you check the documentation, it's got plenty of stuff attached to it, but one of the things that it's got attached to it is this mesh object. So we want to populate this with some kind of mesh. That's what we're trying to accomplish. And in practice, we're going to create a new mesh. So we're going to go mesh, because why not, right? We are original equals new mesh. Great. So we create a new mesh, we assign it to the mesh filter, and that's it. Now, the mesh is currently empty. So again, I'm not sure. I don't think this will actually cause an error unless it complains about the fact that I'm feeding it an empty mesh. But I'm just going to say, I don't think so. I think it's completely valid. Oh, wait. No, there we go. It is completely valid. So now our road has a mesh filter and a mesh renderer, and it actually has a mesh applied to it. It's just a completely empty mesh. So again, you're not actually seeing anything. But all right, so far, hopefully everyone is with me so far. So how do we make our mesh have stuff? Well, I already talked about the vertices and the triangles, so we need to feed it that. And indeed, mesh has vertices, and mesh has triangles. It's a bunch of things. Now, what are the vertices? Well, vertices is an array of vectors, okay? And what are triangles? Triangles is an array of integers. So, let's take a look at what that means. So, vector 3, we have an array of vector 3, and we're going to call this vertices. And we can assign this, oh man, I work in so many programming languages. Is it like this? I think it's like this. We are going to assign an array of vertices. And what are we going to do? Well, we're going to start with a basic square. We're going to create our own plane, but instead of this plane, which is like a huge amount of vertices, we only need to define the 4 corners, right? That's all we need. 4 corners to our plane that we're going to create. Some people, you can refer to as kind of a quad. A quad is, like where I said everything is composed of triangles. Well, in certain 3D modeling programs and also certain video cards and 3D engines and things, instead of working with triangles, you can actually work with quads, which are squares. Squares that follow special rules because they have to be totally flat. So we're sort of kind of going to be creating a quad, but not really. We're going to be creating a plane that's made up of 2 triangles. So it's got 4 vertices, 1 in each corner, and 2 triangles because it, sort of 2 triangles make a square. So what are our vertices going to be? Well, we have to feed it a series of coordinates, and that's fine. So we're going to feed it 4 vertices, 4 vertices, or 4 vectors, right? Because vectors, the way that they're used in Unity, like the term vector in math technically differs from, say, the definition of what a point is, but they're kind of interchangeable here. So we are going to create a square that is, I don't know. Let's say it's a 1 by 1 by 1 square. So I'll tell you what. To make life easy, we'll stick the top the first corner at the 0, 0, 0 point, right? And we're just going to copy this 4 times for our 4 points. And we don't want to mess with the y, because the y coordinate would make our thing go up. And generally, we're going to want something that is flat here. So that's fine. So we're going to make our first one at 1, 1, 1. And then our second point, we're going to move 1 unit over to the right. Okay? Our third point, and think about we're going around the perimeter. So our third point will be 1 unit to the right, and then 1 unit forward. And then our final point will be back over on the left-hand side, but still forward. Okay? So we've defined basically our square will look like, here's the first point, here's the next point, and then the third point is here, and then back to the fourth point here. Hopefully everyone is still with me. So assuming I haven't screwed up the syntax, that is valid. And then we have to set up our triangles. We're going to have 2 triangles. Each triangle is made up of 3 points. And again, it is a series, it's an array of integers. And what are these integers? What do these numbers represent? Well, they represent the number of the vertex that is making up the triangle. So the first triangle will be 0, 1, 2. And the second triangle will be something like 2, 3, 0. Now there's a certain ordering to these, and we're going to see how that, because I guarantee I'm almost certain that this ordering will actually not be correct for what we're looking to do. But this is the basic. This is triangle 1, right? Triangle 1, and then triangle 2. And then we feed that into our mesh. So mesh dot vertices is equal to, well, my vertices that I've created. Mesh dot triangles is equal to the triangles that I've created. And then we apply that mesh to our mesh filter. And this, I think, will work. There will be weirdness. I guarantee you there will be weirdness, but I think this will work. There's one more thing I'm going to do. Because our ground plane is at 0 in terms of height, and because our object, when we create it, get created at 0, 0, 0, they're going to be right on top of each other. And that might mean you can't see the new object, or it might like sort of like half appear, half disappear. It'll look really weird and wrong. So my game object that I'm creating here, I can grab the transform for it, road.transform.position. We're going to set it. Well, I guess I could have used translate here, but that's okay. We'll make it explicit, right? So right now, it's appearing at the 0, 0, 0 point. Well, we're going to make our new object appear just above the 0, just slightly in the y direction. So it's just above our ground plane, and that way it'll guarantee that it's properly visible. Okay, so now that we've got all this code... okay, it is complaining, and this will happen a lot. This won't be a problem if you're working in JavaScript, but if you're working in C#, the problem is when you write a decimal number like this, by default, this is a double, and all of the math in Unity is done on floats. Double is just a double precision float. It's like a way better float in terms of like precision, but it uses up a lot more memory, and the math on it's a little bit slower. So it's actually good and great that it's using normal floats in Unity, but it means you have to stick a little F at the end of it to say, okay, this number is a float, and then Unity will take in this number and be like, oh, okay, everything is awesome. So yeah, that is fine. So if I hit play, and then I hit click, boom. So first of all, you'll notice nothing appeared where my mouse is. That's fine. We don't have anything set up to be mouse driven. All it cares about is the fact that it's clicked. So we've done that, and then we can even zoom in over here. We've indeed created a nice little 4x4 or 1x1 square, a 4-point square. If we look at our wireframe, well, why can't we see it from this point of view? That's funny, you know. You can see the pink here, but all of a sudden you can't see the shape here. But if I go underneath, now I can see the quads or the triangles. Well, what's going on? Well, this is going to be way more obvious if I add a proper material. Let's create, I'm still running the engine, so I can still do this while the engine is running. I'm going to create a material. I'll just leave it called new material, and I'm going to apply this material to the road, because in the mesh renderer, you can see there's a spot for materials, and there's currently no material there. And that's why, first of all, it's this garish purple pink thing. This is the color of a object that has no material whatsoever. And you're going to say, well, that doesn't make any sense. We didn't assign a material to our ground, right? If we pop out of this and we look at the ground, we didn't assign a material to it. No, but default objects have a sort of default built-in grayish diffuse material applied to it, which is why it's well, whitish or grayish depending on the amount of light applied to it, right? So that's why these are visible. But when we create our object in game, there's no default texture applied to it or default material applied to it whatsoever, which is why it's pink. So we're going to take our new gray material. In fact, actually, let me change this to something like bright yellow, so it's going to become super visible here. We're going to make a proper material for this later, or actually pretty soon. You know what? Maybe I should do that now. Let's go back to our ground script. I know you guys just have to deal with the fact that this is done a little bit on the fly here. I don't follow a script as is. In our ground click script, we're going to create a public. We're going to ask for a material, and we're going to call it mat road. Okay. So if we go to ground, we can see that there's a spot for the material, and in fact on the script itself there's a spot for the material, and that's quite cool because you can apply a default on a script wide level, and then in your object, now it didn't populate it right away, what we're gonna have to do is just reset the script, but then you can see it takes the new material. Or if I got rid of this completely, right, if I remove this component and just re-added the component, you can see it uses the default for the script here, and it can be changed. Okay. Now let's run this again. So now when we create our object, it's going to have this yellow new material applied to it. And I'm going to click. No, it's not. Because the mesh renderer is what controls the material. And we're going to say mesh renderer.material equals mat road. Okay, so now it actually gets assigned to it. In fact, I'm going to move this around a little bit because this is the way I like to do it. A little bit more. Just it keeps everything sort of where you would maybe a little bit more expect it to be, right? So we create the object, we move it, then we create the vertices and triangles, populate a mesh, and then we grab our mesh filter from the object, stick the mesh in there, and then finally we grab the mesh renderer and stick the material in there. Sort of step by step. So now if I run it and we hit play, excellent. I've clicked and you can't see anything. Why is that? If I go, I've got a road. It's definitely there. Let me switch back to textured view. Why can't we see it? Well, let me turn the view around here in the editor. Now all of a sudden we can see it. Well, why can we see it from the bottom, but not the top? Well, that's because 3D models, the triangles in most 3D programs, are one-sided. They only show up from one side. They have this thing called back culling enabled. Okay. And actually, before I go on, let me save this scene because it drives me bonkers that it's just sitting there like this. This is just my test scene. All right. And the reason for it, there's several reasons for it, but a lot of it has to come down to, or does come down to performance. Usually you don't see meshes from the backside, so there's no reason for the 3D engine to even think about them, and just ignore anything that you're looking at from the backside, and it saves a lot of kind of CPU performance, or GPU performance, maybe both. And it's a very, very, very good thing, but it can be kind of confusing to people who are experiencing it for the first time. And the reason is that most of your objects should be, like the plane is weird because it's one-sided, but if you've got something like a cube, and let me bring this up. Let me make it quite a bit bigger. That was a typo. There we go. So we've got this cube here, right? And you're looking at the cube from the outside all the time. Well, if I were to move my camera inside, then, well, this is a little weird in the editor actually. You're not supposed to actually see out. Yeah, I can't actually get the view in a sort of satisfying fashion, but theoretically, yeah. If we moved it, what's a better way to doing this? Let's, oh, there we go. Let's do this. Let's put the cube on the camera and then just get rid of the position. And then I don't have to have it inside the camera. I can do that. So now we've got our game camera and it is inside the cube. Well, over here we're looking at it and we don't see the cube, right? If I take this cube and I move it forward and outside of the camera, now I can see it. But when the camera is inside the cube, it can see through the cube walls, therefore proving that the cube triangles are only being rendered on one side. And again, it's a good thing, right? The problem is, in our case, is that our road is the wrong way around. Now, we could rotate it, but we don't want to do that. What it means is that we have to change the order of the triangles, because that's how it determines which side of the triangle is in front and which is behind. It uses a clockwise rotation. If the triangle points are kind of clockwise when you're looking at it, then it'll show up, and if it's anti-clockwise or counterclockwise, then it won't show up, unless I've got that backwards. But it doesn't really matter. What it means is that the ordering here is wrong. Or it can also be changed by tweaking the coordinates. For example, I think if this were -1, -1, then this would effectively, there we go, that would effectively fix the problem. So one solution is to change where your points are. The other solution is to change the ordering of your triangles. So if I change this around, let's say I change this first one to go from 1 to 0 to 2, then, or another way to think about it, it's kind of going 2, 1, 0, right? Because it's all one big loop. Then if I hit play, one of my triangles will be visible and one won't. And I can do the same thing here. And this is usually the way that I resolve it. I change the order that the vertices are applied to my triangle. There we go, all is good. I can't see it from the back, but I can see it from the front. Great. One of the points here I'm going to make is the fact that I try to keep the last vertice of one triangle to be the same as the first vertice of the first one. I'm not sure that this is strictly required. Technically, it's more optimized if you do that. It starts to create these, I don't know, triangle strips and things and whatever, because they share these vertices from one triangle to the other, and there's certain optimizations that I believe they can do. I'm not a master of like high-end 3D graphic card optimization, but I believe that's one of the possibilities. Now, you don't actually have to do this by hand necessarily, because I believe that there is a function called optimize that you can run on the mesh, which I believe will do that sort of stuff for you. I'm not 100% sure. I think Optimize creates triangle strips. It also has a little bit of time to run and all this sort of stuff. You can run it, you can not run it. Listen, don't worry about that sort of stuff. In this particular example, it's way too simple. Like, don't even freak out your brain. When you get like to a big complicated program and you're starting to get performance issues, then you can start thinking about this sort of stuff. But there we go. Okay, so we have our ability to create a simple square. Now, this is not the material we want to use. It looks stupid, right? We can all agree that this material looks ridiculous. Now, we will rename it to be matte road. But what do we want? Well, a material is just a single solid color by default. You need a texture applied to it if you want the material to look anything other than kind of a solid color, right? Let me reset this color to just flat white, first of all. And we want a texture, and a texture is an image file. Now, I happen to have created an image file earlier on. Here we go. Let me bring this into my project. Right, this simple road material. Listen, this was a lot of work in Paint to get these graphics right. You know, I had to fill a square with black, and then I had to draw a yellow line and a couple of white lines. It's hardcore, only the best for you guys. So yeah, so this is the road texture graphic that we're going to use. And it's just going to repeat over and over and over, and it'll look like a road. You'll see. Hang on. So this is our road texture. In fact, I will rename this to Text Road. And so we've got matte road and we've got text road. So in the matte road, in the diffuse color, this is a simple diffuse shader, you'll notice there is a placeholder here for a texture. And we can just drag and drop into it, or we can hit select and then find it. And there we go. So it looks kind of stupid over here, but it's fine. I think, can we not change what the preview object is? Do they have a plane? No, they have a few basic shapes, but that's okay. So we are going to use matte road. Now, did it properly continue to use my, yeah, everything is still connected. Great. So now when I click, well, we just get a black square. Why is that? Shouldn't be colored like this? Why is it black? I mean, it's definitely not yellow, but I also changed the base color to white, so why is this not white? The reason is that it comes down to UV texture mapping. What the hell is UV texture mapping? It's a bit of a topic, so we're going to continue it in the next video.